Okay, you're welcome back to this logarithm class. Okay, now we want to carry out some basic operations using logarithms. So we have here multiplication. I told you we can actually use logarithms to solve problems on multiplication and division. We can also solve problems on powers and roots. Okay, but before we continue, we need to understand basic concepts called laws of logarithm. Okay, let's remember these laws of logarithms. Now, talking about these laws, these will guide us. For instance, when we want to carry out addition or subtraction of numbers, we know the laws. Okay, um, you see something like this: 23 plus 42. You simply add 3 plus 2, 5, 2 plus 4, 6. Then, when you see something like 39 plus 21. You also add 9 plus 1, 10, and you write 10. 3 plus 2, 5. You end up getting 510. Now, this 510 appears correct, but it's wrong. Okay? To you, it's correct, but it's wrong. Why? You assume that whatever you add in the units is the same thing, is kept in the unit, and whatever you add in the tens column is kept in the column. Until your teacher now decides to correct it. Oh, no, this is not how it is done. 9 plus 1 is 10. So you write 0 and carry over 1 to the next column. So 1 plus 3, 4 plus 2, 6. Then you now get the correct answer. Okay, so you're able to obtain and get the correct answers because you now learned the laws, the rules that guide us, addition of numbers. Okay, good. Now, the same thing, if we're going to succeed in solving problems on logarithm, we also need to know the rules. So, one of the rules is when you have something like A times B, in logarithm, it's the same thing as saying log A plus log B. Also, A divided by B in logarithm, that is what? Log A minus log B. Then, when you have something like A raised power n, in logarithm, where n is any value, any power of A, that would be n times log A. Then, if you also have nth root of A, like square root of A or cube root of A, that will be log A divided by n. These are the basic laws of logarithm. So these first two laws, we are going to apply them here to solve problems in logarithms. Okay, so for number one, let's say these are the numbers and these are the log. Okay, so the number here is 2.413 times the second number 3.092. First, we need to obtain their logs. Okay? Now, since 2.413, the decimal is already where it should be. No need to move the decimal any further. The characteristics will be 0. That's the power of 10 will be 0. Okay? Good. So, with our four-figure table, we're going to be checking 24 under 1 difference 3. So 24 under 1 is 3820. Difference 3 is 5. So that will be 3825. So the log will be 0.3825. Now for the second one, the characteristics is also 0 because the decimal is already in standard form, where it should be if it were to be in standard form. So the power of 10 here will be 0. Okay, so I'm going to check 30 under 9 difference 2. So that will be 30 under 9, that's 4900. And difference 2 is 3, so that will be 4903. 4903. Okay, so we found the logarithm of the two numbers. After obtaining the logarithms, now don't forget, when you're multiplying two numbers, a logarithm is the same thing as adding their logs. So we're going to add these logs, and that will give us 5 plus 3 8, 2 plus 0, 2, 8 plus 9, 17. We write 7 and carry over 1. 1 plus 3, 4, plus 4, 8. So that will be 0. Okay, now we've gotten the answer in log. How do we now get the right answer as a value in numbers, since we can use logarithms to solve problems of multiplication and division? We don't need our answer just in logarithm. We need the answer as an actual number, okay, as a numerical value. Then that is where anti-log comes in. Anti-log. Anti here like opposite of logarithm. Okay. Now, if log a means 10 raised power something is equal to a, then it means when you're given the log, if you want to find a, you just say 10 raised power this. Okay? So I can easily say 10 raised power 0.8728 will give me the value. Or I can also I can press that in a calculator, or I can decide to use the anti-logarithm table. Okay? Now, using the anti-logarithm table, I'm going to check 87 under 2 difference 8. So under the anti-logarithm table, just like the logarithm table. So here I'll be checking 87. Okay, 87 under 2. And that gives us 7447. Now difference 8. Difference 8 is 14. So that will be 7447 plus 14. And that gives us 11, we write 1 carry over 1. 1 plus 4, 5 plus 1, 6. So that will be 7461. 7461. Okay? Now, don't forget, if you get a logarithm of numbers, the decimal is usually after the first digit. Okay? So since the characteristics here is 0, we don't need to move the decimal anywhere else. We take it back to where it should be after the first digit. So our answer here will be 7.461. We can also confirm this with our calculator. Okay? Using our calculator here, we'll be having 2.413 times 3.092. Sorry. 2.4413 times 3.092, 3.092. Looks like this calculator is a bit old. Okay. So let's use this. Now, 2.413 times 3.092. Okay, 3.092 times 2.413. Okay, so that gives us 7.4609, which is approximately 7.461. Okay, very good. Now, the same thing can be applied here in question number 2, where we have the numbers and we have the log. Okay, so here we have the two numbers are 527.2 divided by 94.35. So let's find the log of these numbers. 527.2, what should be the characteristics? If you write it in standard form, we are going to be moving this decimal 3 places from the right. Sorry, 2 places from the right. So the characteristics should be 2 points. Now, let's obtain the mantissa. We're going to use our 4-figure table to check the logarithm of, that's 52 under 7 difference 2. So we get here 52 under 7, that's 7218. Now, difference 2 is 2. So 7218. 7218 plus 2 is the recurrent of 1, 2. So that would be 2.7220. Now let's look at the next one. Here we have 94.35. If I write it in standard form, I only have to move the decimal once. So the characteristics here will be 1 point. I only have to move the decimal 1 from the right. Okay? The characteristics will be 1 point. Now I'll use my 4-figure table, that's my logarithm table, to check the mantissa, which is 94 under 3. 94 under 3, that's 9745. Difference 5, and difference 5 here is 2. So we have 9745 plus 2, and that will give us 747. So that will be 9747. 9747. Now, don't forget, in logarithm of numbers, we're going to do something. When we're dividing the numbers, it's the same thing as subtracting the log. So we're going to subtract this, and that will be giving us 0 minus 7. You can go through, we take 1 from here, 1. So 10 minus 7 as 3. 1 minus 4 can go through. I will take this, take 1 from here, this is 1. 11 minus 4 is 7. Now 1 minus 7 can go through. I'll take 1 from here, it means 6. So 11 minus 7 here is 4. Now 6 minus 9 can go through. I'll take 1 from here, it means 1. 16 minus 9 is 7. And 1 minus 1 is 0. Okay? So, now, to get the actual value, whose log is 0.7473, I'll find the antilog. With my calculator, I can either press the shift log to get the antilog, or with my 4-figure table, I can also find the antilog. Or I can still say 10 raised power 0.7473. Okay, good. So since you're using the 4-figure table, I'll continue with that. So I'm going to check in the anti-logarithm table 74 under 7 difference 3. So that will be 74 under 7. That's 5585. 5585. Now difference 3. Difference 3 is 4. I write down 4. So if I add it, that will be 5589. So I'll be having 5589. So since the characteristics is 0, I just have to write, I'll just have to leave the decimal where it should be in standard form without moving it.